Okay, 2.1, number 79. We have the function f of x is equal to x minus 6 to the 2/3, and they're telling us that c is equal to 6. Sorry about that. Okay, they want us to use the alternate form of a derivative. Okay, you have to know all three. This one says the limit as x approaches c of f of x minus f of c all over x minus c. Okay, let's just fill in what we have. So we actually have the limit as x goes to 6 of f of x minus f of 6 all over x minus 6. Okay, off to the races here. Let's just fill in what we have and see what we can do. Well, f of x is just x minus 6 to the 2/3 minus, now we're putting a 6 in, so that's 6 minus 6 to the 2/3. That's interesting. And we also still have x minus 6 on the bottom. If you see that 6 minus 6 goes to 0, we don't have to worry about that guy. And we're left with the limit as x goes to 6 of x minus 6 to the 2/3 over x minus 6. And from pre-calc, we know that we can write x to the m over x to the n, or, you know what, let's use letters here. So a to the m over a to the n is equal to 1 over a to the n minus m. So using that property from pre-calculus, right, there's a little power of 1 there. That's equal to the limit as x goes to 6 of 1 over x minus 6. Let's see, 1 minus 2/3 is 1/3. And this is something we're going to talk about in class again. But if we apply this limit, we get the form, okay? So you have to be thinking 1 over 0, okay? So right here, what we would write, we would say this guy goes to infinity. Therefore, this guy does not exist. And the reason for that is because when the denominator gets really, really big, really, really small, I should say 0, you can think of it as, well, if I had 1 over 1/2, then 1 over 120. So as the denominator is getting smaller and smaller, okay, as it's going towards 0, I'm going the wrong way actually. Let me try that again. So let's say I started off with 1/2, and then I went smaller. 1, what's going on here? 1/2, even smaller, 1 over 1/20th. Well, these numbers actually will flip. So 1 over 1 times 1 over 2 is actually equal to 1 over 1 times 2 over 1, which is equal to 2. 1 over 120 is 1 over 1 times 20 over 1, which is 20. So as your denominators are getting smaller, as they're going towards 0, these numbers are actually getting really, really big. In fact, they're all going to infinity. So that's why we can say that this guy doesn't exist. Just to make that point clearer, sometimes we like to think of the function, f of x is equal to 1 over x. And we know what that function looks like. It's the reciprocal function. Okay. And, you know, if we went this way with x, we'd be going towards infinity. And if we went this way, we're going towards 0. And if we're going towards infinity, you can see this guy's getting really, really small. So as x gets big, this function, okay, gets really small. So as x goes to infinity, f of x goes to 0. However, if we take x in the other direction, look what's happening to our y values. They're all getting really, really big. So we can say something like, as x goes towards 0, f of x goes to infinity, and therefore we say it doesn't exist. See, this one exists. 0 is fine, but we can't go towards infinity. But again, we'll talk about this again in class.